Okay, so let's define the structures and mechanisms subsystem and its responsibilities in the context of a spacecraft. So the structures subsystem is the mechanical structure and supports that keep a spacecraft physically together. There are different categories of the structure itself. There's a primary, a secondary, and at times a tertiary structure if you have something large enough that needs this hierarchy. For our Artemis CubeSat, there's the primary and the secondary, and there's not much tertiary to describe. But let's look at something like this, something that isn't the Artemis CubeSat. Here's a larger spacecraft where the primary structure is this hexagonal frame. The primary structure, its responsibility is to take on the major loads of the spacecraft. The major loads could be the launch acceleration and vibration, or the acceleration from propulsive maneuvers during the mission. The secondary structure they're not exactly load-bearing, although they do have some load associated with them, but they're not critical when it comes to the structural integrity of the overall structure. They can be things like these mounting box brackets. They can also be other structural mechanisms like if there's a boom or if there's a bracket that supports these other instruments. But you can see how they're secondary to the overall structure. For the CubeSat, here you'll see an exploded view of the different components inside. So I'll go over how the primary structure, just to review, is the rigid exoskeleton, and then the secondary structure bridges the different components to the primary structure. So you can imagine that this exoskeleton, that frame right there, that is the primary structure. And the secondary structure are the threaded rods that keep all the boards in place, and also the different spacers that keep the boards spaced uniformly across that height. Secondary structures can also be those shear panels. These faces of either plastic or aluminum have solar panels mounted to them, solar cells mounted to them, but they're not exactly load-bearing in the way that it's supporting all of the, say, compressive force from the P-pod deployer or during acceleration.